First of all, we have the introduction about our research. This research about evaluation of traffic performance in Bekasi City based on big data is expected to produce an easier and more accurate method in collecting travel speed data on the road network. It serves as a means of evaluating various traffic management practices implemented in an effort to improve road network performance. The population of the city of Bekasi is more than 3 million people spread over 12 sub-districts, consisting of 56 urban villages. The objectives of this research are: first, knowing the performance of travel speed in the study area resulting from the extraction of traffic data from big data and the results of manual surveys. Second, knowing the prediction of congestion time that occurs in the cities in the study area network. Third, knowing the result of the comparison between the extracted data and the results of the manual survey. Bekasi City is one of the Jakarta buffer cities that are included in the Jabodetabek agglomeration. Of course, this is very influential in the characteristic of the traffic in the city. In this study, not all roads were taken as the study area. Only 2 roads that are taken as study area in Bekasi City area. Why these roads? Because this road section is the main road that connects the area between East Bekasi and West Bekasi. The road section in question are Chutmutia Street and Ahmad Yani Street. In Bekasi, it's along about 4.2 kilometers. This determination is precisely starting from Chutmutia Street in front of the Unisma Bekasi campus to Ahmad Yani Street in front of the Patriot Chandrabaga Stadium, Bekasi City. The stage of this research carried out can be seen in this picture, which begins with the identification of problems, followed by data collection, both secondary and primary. The secondary data in the form of road network data and road length is converted into spatial data, which can then run using the Google API to get speed data from the data extraction from Google Maps. While primary data is data from a survey to determine the actual speed in the field. The use of Google Maps the use of the Google Maps, which display the latest data, is very massive in the community. This real-time data ecosystem builds what is called big data, a mechanism for updating information related to real events in the public environment, with the potential benefit of using big data. This study tries to extract data collected from location service application into one of the indicators of traffic performance. Furthermore, it will compare the result of the data extraction with the processing of the data from the survey results directly in the field using the manual method commonly used. As you can see, this picture in this slide is the street of the Chutmutia Street until Ahmad Yani Street in this study area. Traffic performance by using Google API. In this slide, we can see the picture about the Spider application. Bringing up the Google Maps on the menu, and as you can see, this one in this picture is coordinate input data, and this study simulated traffic prediction for weekdays and weekends. Time for weekdays is simulated on Monday, October 18, 2021, while for weekends it is simulated on Saturday in 16th of October and 2021. After running the Spider application and the CSV file will be obtained in the form of the output of the traffic simulation at a predetermined time. As previously stated, the study area in this research consists of two road segments, which are divided into 6 nodes to get the performance of each direction. From the data obtained from BIGDATA, Google will generate speed values every hour in 1 day. Then, the average travel speed per hour is obtained so that it can denote the time from the lowest to the highest speed condition in 1 day. This is the result from the Google API extraction. As you can see, it's speed values every hour in 1 day. In this slide, the following is a comparison of the average speed between the weekend and weekdays in the Unisma until the gas station segment. As you can see in the graph, in general, there is no significant difference between the speed on weekend and weekdays. The speed tends to decrease from morning to noon, with the lowest speed position on weekends at 12 until 1 p.m., which is 19.2 kilometers per hour. And the second, we can see this condition in 1.6 kilometers gas station until stadium segment is simulated to get the traffic performance in the form of the travel time and average travel speed in that segment. In this segment, the speed tends to decrease from morning to noon with the lowest speed position and on the weekdays. As you can see, this red line is weekdays at the 8 until 19 p.m. with an average speed of 25.1 kilometers per hour. In the stadium until gas station segment, the direction of Pakayon is 1.6 kilometers in the opposite direction from the gas station until stadium segment with the same land use characteristic. In the segment, there is a U-turn facility around the front of the hospital, which is quite obstructing the flow. In addition, there is a merging conflict between the flow from the Sumarkan flyover and the flow from the bottom. The following is a comparison of the average speed between weekend and weekdays in the stadium until gas station segment. If you look at the graph in the picture, there is a significant difference between the speed on weekend and weekdays. The speed on the weekend decreased quite drastically when compared to the speed on weekdays, as you can see like this. This may be influenced by trade and service activities around the stadium and gas station segment, which causes low speeds. The speeds tend to decrease from early morning to midday to the lowest speed position during the weekend at 3 p.m. until 4 p.m. with an average speed of 14.7 kilometers per hour. The last is the gas station until Unisma segment. This segment with a length of 2.6 kilometers in the opposite direction from the Unisma until gas station segment, with more or less the same land use characteristic. Um, the following is a comparison of the average speed between weekend and weekdays in the gas station segment until Unisma. As you can see in this picture, there is no significant difference between the speed on weekend and weekdays. The speed tends to decrease from noon, with the lowest speed position on weekdays at 6 p.m. until 7 p.m. with an average speed of 26.3 kilometers per hour. In this slide, it's about traffic performance results from manual survey. In addition to conducting simulation using big data obtained from Google Maps, this study also conducted a direct field survey using the usual method of obtaining the average travel time, namely the moving car observer method. This survey was conducted on the same day as the simulation they used during the extraction of Google Big Data, namely is Saturday in 6th of October in 2021 for weekend condition, and Monday in 18th of October 2021 for weekday condition. This is done to be able to see the difference in the result between the simulation result of traffic performance from running the application and the condition that occur in the field, which is then tested whether it is appropriate or has a large deviation between the speed of the extraction result and field condition. Due to various research limitations, the moving car observer survey, which was carried out not for 24 hours, was carried out like the output from the Google Big Data extraction. This survey was only conducted for 2 sessions per day, each session for 2 hours. The morning session is held at 7 until 9 a.m. In the afternoon session is held at 12 until 14 p.m. and the afternoon session is held at the 4 until 6 p.m. The survey was conducted with an average of 2 round-trip times every hour, so that the average speed data obtained each hour is the average speed data from 2 trips, as you can see, in weekday and weekends. If the table compares this data with the result of Google Maps Big Data extraction, the comparison of each segment is found in the graphs in this picture. As you can see, based on the comparison of the speed, the simulation's result with the survey above, there are indeed differences in each time session. However, in general, there is actually no significant difference between the simulation results and the survey. If it is seen that the average speed of the survey results tends to be higher than the simulation results, it is possible that the results of the extraction carried out by Google API are the average speed with a longer data collection time base, and have taken into account all mobile phone users who enable location without discriminating the type of vehicle. This slide is about the performance result comparison. As you can see, it have two tables in this picture. It's weekday volume speed validation and weekend volume speed validation. It's to find out the significance of the difference in data from traffic simulation results that have been carried out with the previous Google API. Validation is needed to this. The validation of the simulation result is intended to test whether the simulation results obtained have a significant difference with the survey results. So, that the simulation result can be accepted. If there is a difference that is not too significant, then the results are acceptable. If there is a significant difference, then the model cannot be accepted. The validation of the simulation result is based on the result of the chi-square test between the result of the traffic survey and the simulation result that have been made. The last, as the conclusion, based on the result of research in the utilization of big data in this traffic field, the following conclusion can be obtained. First, based on the result of processing and utilization of big data from Google Maps, it's known that there are methods that can be used to get prediction of traffic performance in the form of fluctuation in travel speed with complete data throughout the day and fairly easy way compared to conventional survey methods. Second, by getting the flux of travel speed in one day, it is obtained a prediction of the time of congestion that occurs on the road or network. The speed decreased from noon at 9 a.m. to evening at 7 p.m. A significant decrease was found in the stadium's gas station segment, which reached the lowest speed on the weekend at 3 until 4 p.m. with an average speed of 14.7 kilometers per hour. Third, result from validity test on Google API extraction simulation data with conventional survey results. It is known that the performance of simulation result is still valid and worth using as a data collection method. Finally, thank you for your attention and listening to my presentation. See you next time and wassalamualaikum warahmatullahi wabarakatuh.